You think you know what you're asking when you ask, why do magnets repel? You don't. And until you understand why your question is broken, you're going to be frustrated by every answer anyone gives you, including mine. Let me show you the problem. Pick up two magnets, North Pole to North Pole. Feel that push, that invisible resistance in empty air. You want to know why. You want me to say magnets repel for the same reason that, and then fill in the blank with something familiar. Rubber bands, springs, two hands pushing against each other, something you already understand. Here's the thing. There is no familiar thing. And I'm not being difficult. I'm not hiding behind complexity. I'm telling you the truth that most people don't want to hear. Magnetic forces are fundamental. They're rock bottom. There's nothing underneath them to compare them to. You're asking me to explain electromagnetism by comparing it to something simpler. But there isn't anything simpler. That's like asking me to explain arithmetic by using something more basic than numbers. Can't be done. Now you're thinking, wait, I've heard explanations. Magnetic fields, electrons spinning, those sound like deeper explanations.
You think you know what you're asking when you ask, why do magnets repel? You don't. And until you understand why your question is broken, you're going to be frustrated by every answer anyone gives you, including mine. Let me show you the problem. Pick up two magnets, North Pole to North Pole. Feel that push, that invisible resistance in empty air. You want to know why. You want me to say magnets repel for the same reason that, and then fill in the blank with something familiar. Rubber bands, springs, two hands pushing against each other, something you already understand. Here's the thing. There is no familiar thing. And I'm not being difficult. I'm not hiding behind complexity. I'm telling you the truth that most people don't want to hear. Magnetic forces are fundamental. They're rock bottom. There's nothing underneath them to compare them to. You're asking me to explain electromagnetism by comparing it to something simpler. But there isn't anything simpler. That's like asking me to explain arithmetic by using something more basic than numbers. Can't be done. Now you're thinking, wait, I've heard explanations. Magnetic fields, electrons spinning, those sound like deeper explanations. No, they're descriptions. Very precise, very accurate descriptions. They tell you how the force behaves, not why it exists in the first place. And you need to understand the difference between those two things, or this entire conversation is pointless. Let me ask you something. Push your hand down on your desk right now. Go ahead, push hard. Why doesn't your hand go through? You'll probably say, because the desk is solid. Wrong. Not wrong because the desk isn't solid, it is, but wrong because that's not an explanation. That's just another label for the thing you're trying to understand. Try again. Why doesn't your hand pass through? Because the atoms are packed together. Better, keep going. Why don't the atoms in your hand pass through the atoms in the desk? Because atoms are solid too. No, stop. Think about this. Atoms are not solid. An atom, it's mostly empty space. If you scaled an atom up to the size of a football stadium, the nucleus would be a pea at the center. The electrons would be tiny dots way out near the seats. Everything in between is empty space. Your hand is essentially all empty space. The desk is essentially all empty space. So why don't they pass through each other? You're starting to get uncomfortable now. Good, you should be. The answer is electromagnetic repulsion between electrons. The electrons in your hand and the electrons in the desk have the same charge. Like charges repel. So when you push down, you're feeling trillions of tiny electromagnetic interactions all adding up to what you call solid. Now here's the question that's going to really bother you. Why do like charges repel? You can't answer that, can you? You can say electromagnetic force, but that's just giving it a name. That's not explaining anything. It's like saying, why do magnets repel? Because of magnetic force. That's circular. That's not an explanation. The electromagnetic force is one of four fundamental forces in nature. It's not caused by something else, it's not derived from something simpler, it just is. And here's what nobody tells you. The force that stops your hand at the desk surface, that's the exact same force that makes magnets push apart. The same force, not similar, not analogous, identical. The electromagnetic force. So why does one feel obvious and the other feel mysterious?
I'll tell you why. You've been pushing on solid objects since you were 6 months old. By the time you were 2, your brain had built up an enormous library of experiences. Pushing, grabbing, falling down, hitting the ground. Your neurons wired themselves around those experiences. They built patterns, expectations, a whole intuitive framework. So now when you push on a desk, it feels normal, natural, obvious. You don't think about it. You don't think it needs explaining. But magnets? Magnets push through empty space. You can see the gap. You can slide a piece of paper through. There's nothing there. That feels weird. That feels wrong. That feels like it needs an explanation. But here's the truth. The weirdness is in your head, not in the physics. When you push on the desk, the electrons in your hand never actually touch the electrons in the desk. They repel at a distance, a tiny distance, a few atomic widths, but still a distance. We call it contact because the distance is too small to see, but it's not really contact. Nothing is touching. It's electromagnetic repulsion operating across a gap. With magnets, the gap is bigger. A centimeter, an inch, big enough to see, big enough to make you uncomfortable. But the force is the same. The mechanism is the same. The only difference is scale. The mystery you feel is not a mystery in the physics. It's a mystery in your psychology. You're comfortable with electromagnetic repulsion at atomic distances because you've experienced it your whole life. You're uncomfortable with electromagnetic repulsion at centimeter distances because it's less familiar. That's it. That's the whole difference. Now you're probably thinking, okay, fine, but surely quantum mechanics explains why the electromagnetic force exists. Wrong. Again, quantum electrodynamics, the quantum theory of electromagnetism, is the most precisely tested theory in all of science. We've measured certain predictions to 11 decimal places, and the theory matches exactly. But here's what QED does. It tells you how to calculate electromagnetic interactions with absurd precision. It gives you rules, equations, predictive power. What it does not do is tell you why the electromagnetic force exists in some deep philosophical sense. It describes the force beautifully, perfectly, but it doesn't explain it away. It doesn't reduce it to something simpler, because there isn't anything simpler. Let me show you how this works with a different example. You ask, why does ice float on water? I can tell you because ice is less dense than liquid water. Why is it less dense? Because the molecular structure has more space between the molecules.
Because of the quantum mechanical properties of electrons in water molecules. Why do electrons have those properties? Because of the Schrödinger equation and the Pauli exclusion principle. Why do those equations hold? See what's happening at each step? I'm giving you a deeper answer, but I'm also just pushing the question back one level. Eventually, and this happens fast, you hit bedrock, the fundamental equations, the basic forces. And there, the only honest answer is, that's what we measure. That's what the universe does. We can describe it mathematically. We can test it experimentally. We can use it to make predictions and build technology. But we can't explain it in terms of something more fundamental, because there isn't anything more fundamental. The chain of why has to end somewhere. Here's the deep problem with your question about magnets. When you ask why, you're not really asking for information, you're asking for comfort. You're asking me to connect the unfamiliar thing to something familiar so you can stop feeling confused. You want a story, a narrative, a chain of cause and effect that ends with something you already understand. But magnets repel because of the electromagnetic force, and the electromagnetic force exists because that's a fundamental property of the universe. There's no story, there's no deeper because, there's just measurement and mathematics. Now, I know that's not satisfying, I know you want more, but the universe doesn't care what you want. The universe is what it is. Let me tell you what really bothers me about this question. You're treating magnets like they're special, like they're the one weird thing in a universe of normal things. That's backwards. Everything is electromagnetic if you look closely enough. Why do chemicals react? Electromagnetic forces rearranging electrons. Why does light bounce off mirrors? Electromagnetic interaction. Why do you see colors? Electromagnetic radiation hitting your retina. Why does your computer work? Electromagnetic forces moving electrons through circuits. The electromagnetic force isn't some exotic phenomenon that only shows up in magnets. It's everywhere. It's the dominant force in your entire life. Gravity, weaker by a factor of 10 to the 36th, completely irrelevant for atoms and molecules. The strong and weak nuclear forces locked inside atomic nuclei, too short range to affect anything you can touch. Everything else, and I mean everything, is electromagnetism. The force making magnets push apart is the same force holding your body together right now, the same force preventing you from falling through your chair, the same force letting you read these words.
Why does it have that structure? Because of how hydrogen bonds arrange themselves at freezing temperatures. Why do hydrogen bonds arrange that way? So when you ask me to explain magnetic repulsion by comparing it to something normal, you're asking me to explain electromagnetism using electromagnetism. It's circular. Can't be done. Let me try a different approach. Maybe this'll help. You know how you can explain the color blue to someone who can see? You show them the sky, a blue shirt, you give examples. But how do you explain blue to someone blind from birth? You can talk about wavelengths about 450 nanometers. You can describe where it sits between red and green in the spectrum. You can give them all the physics of blue, but none of that conveys the experience, the actual blue. They have to see it. There's no shortcut. Same with magnets, same with electromagnetism. You don't get the intuition from an analogy. You don't get it from a 5-minute explanation. You have to work with the mathematics, solve problems, make calculations, predictions, test them. After months, maybe years of working with electromagnetic theory, something shifts in your brain. The equations start to feel natural, intuitive, obvious. Not because they match your everyday experience, but because you've built a new everyday experience, mathematical experience, experience with how fields behave. And then magnets aren't mysterious anymore. They're exactly what you'd expect, inevitable consequences of charged particles and fields. But you can't shortcut that process. You can't skip to the end. You have to earn the intuition. Now let me tell you what I can give you. The technical answer. Magnets have magnetic dipole moments, little arrows of magnetism. When you align lots of them in the same direction, you get a permanent magnet. Those dipoles create a magnetic field configuration that stores potential energy. Physical systems naturally evolve toward lower energy states. When two north poles face each other, the energy is high. Moving them apart lowers the energy, so they repel. That's the answer. That's as deep as it goes. You want to know why dipoles create fields? I can tell you about moving charges and electron spin. You want to know why electrons have spin? I can tell you about the Dirac equation and quantum mechanics. You want to know why the Dirac equation is correct? I can tell you it follows from combining special relativity with quantum mechanics. You want to know why those theories hold? Because they match reality. Because we've tested them millions of times and they work. That's it. That's where the chain ends. Here's what you need to understand about how physics actually works. We don't start with philosophy and derive the universe. We start with measurements. We observe patterns. We write equations that describe those patterns. We test those equations against new experiments.
When the equations work, when they let us predict things we haven't seen yet, we say we understand the phenomenon. Understanding in physics doesn't mean philosophical satisfaction. It doesn't mean matching your intuition. It means predictive power. It means being able to calculate, to predict, to build technology that works. By that standard, we understand electromagnetism better than almost anything. Quantum electrodynamics is tested to incredible precision. We can calculate the magnetic moment of an electron to 11 decimal places, and the measurement agrees exactly. So when I say I understand magnets, I mean this. I can calculate the force between them. I can predict how they'll behave in different configurations. I can design electric motors, generators, MRI machines. I can manipulate magnetic fields to trap particles or focus beams. That's real understanding. That's what physics offers, not comfort, not familiar analogies, but power, control over nature. You might not like this answer. You might find it unsatisfying, tough. The universe doesn't owe you an explanation that makes you comfortable. It doesn't owe you a story that matches your intuition about how things should work. Your intuition evolved to throw rocks, pick fruit, and avoid predators on the African savanna. It did not evolve to understand quantum fields or electromagnetic interactions at the atomic scale. So when physics reveals something that violates your intuition, particles acting like waves, time slowing down at high speeds, magnets pushing through empty space, you have two choices. You can reject it as mysterious and unsatisfying and keep asking for better explanations that don't exist. Or you can expand your intuition, learn the mathematics, work through the problems, build new mental models based on equations and experiments, not everyday experience. That's what physicists do. None of us found quantum mechanics intuitive at first, but we worked with it long enough that it became familiar, and eventually it started to feel natural. Not because it matches common sense, but because we built new common sense, mathematical common sense. So here's what I want you to take away from this. The next time you pick up two magnets and feel them push apart, don't ask why, ask how. How does the force depend on distance? How strong is it compared to gravity? How can I calculate it? How can I use it? Those questions have answers, good answers, precise answers, beautiful answers.
The why question, the one asking for reduction to something more familiar, that question doesn't have an answer. Not for magnets, not for any fundamental force, because fundamental means exactly that, bottom level, nothing underneath. But here's the beautiful thing that people miss when they get stuck on why. What physics reveals is that the universe operates according to a small set of rules. The same equations that describe magnets also describe lightning, brain signals, computer chips, the northern lights, chemical bonds, why stars shine, why atoms are stable. That's not a failure to explain. That's unification. That's discovering that underneath all the apparent complexity and chaos of nature, there's a deep structure, a mathematical structure, simple rules with incredibly complex consequences. That's what should blow your mind. Not that we can't reduce magnets to something simpler, but that we can reduce thousands of seemingly different phenomena to the same underlying force. You wanted me to explain magnets by comparing them to something familiar, but I'm telling you something better. Everything familiar is actually magnets. Or rather, everything is electromagnetism. Same thing. Your desk, your body, the air, light, chemistry, life itself. It's all different arrangements of electromagnetic interactions. You're not separate from the magnets. You're made of the same force. So, was my refusal to answer the BBC interviewer arrogant? No, it was honest. I could have given him a comfortable lie. Magnets are like springs, or think of magnetic fields as rubber sheets, or whatever would have made him nod and feel satisfied.
And he would have learned nothing. Instead, I told him the truth. The question itself was broken. The kind of why he wanted doesn't exist. At the fundamental level, things just are. And our job is to describe them accurately, not to reduce them to something more comfortable. People hated that answer, called it evasive, called it a failure to communicate, but they were wrong. Sometimes the most honest answer is the universe doesn't work the way you expect. Your intuitions are wrong. And if you want to understand what's really happening, you need to learn a new way of thinking. That's not arrogance, that's respect. Respect for the truth, respect for the actual structure of reality, and respect for you, for your ability to handle that truth instead of needing a comfortable fiction. So, pick up those magnets one more time. Feel that invisible push. Now understand you're feeling one of the 4 fundamental forces of nature. The same force that makes chemistry work, the same force that makes stars shine, the same force holding you together right now. That's not mysterious, that's magnificent. And the fact that we can describe it with equations, test it with experiments, and use it to build technology, that's not a failure to explain. That's what understanding actually looks like.